Good morning, everyone. My name is Richard Allen. I'm the CEO of the British Frozen Food Federation. Thank you for joining this webinar this morning. Although this meeting will be held online, it will be held under Chatham House rules. Whilst points and comments can be discussed outside of the group, nothing can be attributed to a company or person. In any questions or comments, please be aware of competition rules and that only information in the public domain can be declared. I appreciate that this is an online meeting and these two things are unlikely to happen, but I think it is only right that we are absolutely clear regarding competition rules. I've already asked everyone please to mute your microphones as the background noise can be quite off-putting. So could you would just please all make certain you do that, we'd appreciate it. Okay, so a little bit of an overview as to why we've organised this webinar. I think everyone's aware that we should all be looking at ways to reduce the amount of packaging we use. Now, this particular webinar will focus on plastic film. This can be a thinner film or even less headspace in packaging. Now, obviously, the reason that we're doing this is for environmental considerations. We're seeing a lot of pressure from consumers and end users to have a much more positive approach to the environment and have less impact. From a business perspective, it makes lots of sense because we need to control the costs around packaging. And in fact, the recycling costs of packaging are actually going up exponentially. We'll come on and talk about that a little bit later. But I think one of the other very important points is that as sustainability and food wastage becomes a more important aspect of impact on the environment, frozen food has a magnificent position to talk about the ways we can help consumers and professional kitchens reduce, whether that's in terms of production, the type of packaging we use, the storage systems and the transport systems. So this is part of a much wider position where we can have a very positive story to tell around helping people, but we must also be seen to actually be working very hard to have a very good sustainable message. Now, in terms of plastic, as I've already mentioned, this can be thinner film or even less headspace in packaging, or possibly different types of material. I think the problem with different types of material is a lot of them at the moment are not at scale, and we actually need to tap into areas where we can have materials of scale in order to continue to pack product properly. However, the problems that we're facing are quite large in their scale, and we actually believe that the best way to solve this is by working in collaboration to try and move forward as much as we can as an industry. This is some information in terms of what's happened with PRN cost profiles from 2017 to 2018. And as you can see, the blue line, which is starting to escalate up towards the back end of 2018 is the plastic cost. The one above it is aluminium costs. You can see what happened then in 2018 through to October 2019, where we've seen a dramatic rise in the cost of plastic. And I'm sure you're all aware of that when you're actually signing off your invoices for PRNs have actually gone up quite dramatically. At one point, PRNs, according to the European Recycling Platform, had actually exceeded £400 a tonne, although they have softened a little towards the back end of the year. But even then, as we come into December, they were still standing at something like £289 a tonne, which is nearly 10 times what they were back in early 2017. So, as I've stated, we're already seeing a significant impact on cost, especially around plastic. The European Recycling Platform, EPR, estimate that industry pays about 7 to 9% of total recycling costs. There's a lot of discussion at the moment that government are looking to extend the producer responsibility, possibly by the end of 2022, and it is likely that they will actually push more cost onto industry for recycling. So it is actually impacting our bottom line to try and find ways to reduce our packaging that we use. As I've said, EPR estimate PRM plastic reached £350 a tonne in October. Interesting enough, in Germany, where they've introduced a new scheme last year, plastic recycling is now up to £700 a tonne. So the BFF have organised this webinar to share information from ExxonMobil. They contacted us in late 2019 to outline ideas to reduce the gauge on film used for form film repack, claiming up to a 33% reduction was possible. So after this, ExxonMobil will actually present the information they have, and then we can actually see whether their ideas are viable. We also want to look to use this platform to launch a specialist interest group to look at ways to reduce not only plastic, but all packaging materials in the frozen food industry. Whilst we see lots of work in reducing packaging across many categories, our unique storage temperature is essential that we ensure any new materials or reduction to existing materials are fit for purpose in frozen. Now, during the webinar, there is an opportunity to post questions. At the bottom of your screen, you should see a little bubble. If you press on the bubble, a screen comes up on the right-hand side, and you can post questions there. You can either post them to everyone, or you can post them to Emil from ExxonMobil, and then we will try and answer those at the back end of the meeting if we have time. We're also happy to answer questions after the event. If you have any questions, please email any further questions to Holly. And any questions that are asked during the webinar that we don't actually get time to answer, we will follow up with the people who asked the questions. So I'll now hand over to our two experts from ExxonMobil who will introduce themselves. It's Marcus and Emil. So guys, over to you.
Thank you very much, Richard. Good morning, everybody. So thanks, Richard, again for hosting this event. We are very happy to be part of it. My name is Amélie Dirstein. I have been working for ExxonMobil for the last 10 years. Currently, I handle a portfolio of customers in Europe, and I'm also a member of ExxonMobil Flexible Food Packaging Network. Together with me today, we have Marcus Freeman. So during his 20 years with ExxonMobil, he has had several positions in sales, but also in technology, and he is now a market developer. And he is also a member of the Flexible Food Packaging Network within ExxonMobil.
Thank you, Amélie. Good morning to everyone. My name is Marcus, and with Amélie, I will share this ExxonMobil part of this webinar. And to start off with, I want to give you a very short introduction to ExxonMobil Chemical. So ExxonMobil Chemical is a part of the US-based energy company ExxonMobil Corporation. Our business model is to be the leader, so we want to be number one and number two in every market we want to be active in. And one of our main competitive advantages is the fact that we have a fully integrated business model. So we have access to crude oil as well as gas, which we then separate into downstream operations and to chemical. So the downstream operations would be fuel and lubrications. And from the chemicals, first of all, we sell chemicals, but we also produce products. So in this seminar, we're going to talk about our polyethylene and polypropylene business. And this is an area where we are market leader. And one of the main reasons why we have become one of the market leaders in polyethylene and polypropylene is that we have been running the forefront of research and development. So Richard touched this already a little bit in his introduction. The fact is that since 2000, global polymer demand has doubled. But at the same time, we are only collecting 14% of all the plastic packaging for recycling. And that's a global number. On a European number, we are slightly better with 30%. However, mismanaged plastic waste is the main reason for why we're having this call today. You've all seen those pictures of waste in the nature. We have heard the prediction that during our lifetime, if we continue at the same rate, there might be more plastic than fish in the ocean. Yeah. These are very compelling cases to the consumer, and that's why also we have seen that the consumer perception about plastic packaging is not as good as it used to be. And as an industry, we have to respond to this consumer perception. To start off, there were good reasons why plastic packaging became so popular from the beginning. It's lightweight, it's low cost, and it brings very high package integrity as well as consumer convenience. Today, in many of the applications, there are no real alternatives to substitute plastic packaging while maintaining the integrity and shelf life. At ExxonMobil, we have several solutions to make flexible plastic packaging more sustainable. And during this webinar, we will discuss this further. This is the slide we are seeing currently. This is governmental data on the UK waste situation. So according to this public data, this is data presented in 2017, and it's based on 2016. So just to give you a picture, so in UK, 223 million tons in total are produced every year. This is including demolition and construction waste and soils, etc. Those two accounts for roughly half of it. But out of those 223 million tons, 100 million tons is recovered and recycled. But still, 52 million tons goes to landfill. And if we then zoom in on packaging, so the UK packaging waste is 11.5 million tons. And out of these 11.5 million tons, only 20% is plastic packaging waste. So this again shows the fact that plastic packaging is very lightweight compared with, for example, glass, metal, and cardboard. And half of it roughly is recovered or recycled. That's a good number for being plastics, but it's still far behind like cardboard and etc. So this tells us that about 1 million tons of plastic packaging in the UK is either landfilled or incinerated. So there is still room for improvement. If we then move on, at ExxonMobil, we embrace the 3 R's, reuse, reduce, and recycle. So if we start from the top, reuse is not much of an option in frozen food packaging currently. There are many reasons for this. Food law certification is one of them. So for this seminar, we will have to focus on the 2 others. So we will focus on reduce and recycle. So the question you have is, why don't we sell the same amount of frozen food but do it with using less plastic? And with the polymers existing in the past, it wasn't possible to make the flexible packaging thinner without compromising the performance. But this is no longer the case. Thanks to our latest development of newer and tougher polymers, we can push beyond the capabilities of the current market reference. So that's one way. We can make package thinner. So what can we do in the area of recycling? So said that we have very stringent food law requirements on food packaging. So currently that limits the possibility to include recycled material into primary food packaging. However, it's our responsibility to make sure that the frozen food packaging, once it's used, can be fed into the recycling loop for other applications. And this isn't always the case today, and that's why design for recycle has become a hot topic in food packaging. In a few slides, we will talk more about material reduction as well as how to design for recycle. Before going there, I would like to give you just a feeling for the size of the freezer film market. Our last revision of this presentation was done based on 2016 data. And already then you see on the right-hand side that the PE freezer film market accounts for 1.5 million tons globally. The European part is, based on our estimates, currently 185,000 tons. And as we see, good for you that frozen food is growing in popularity. So the demand for packaging material for frozen food is also growing. So we predict here for European Union or Europe to be growing at a pace slightly higher than GDP. To get everyone on the same page when we talk about frozen food packaging, there are 2 types of film for frozen food. So one is laminated and the other one is non-laminated. So if we start with looking at the non-laminated one, the one you have to the left on the screen, it is what we call a monomaterial structure. It consists of only polyethylene in this case, and they are easy to recycle if there is an existing recycle stream. Printing has to be done on the outside of the package, so printing quality might be defensive when we're talking about non-laminated structures. This packaging type is, however, cheaper, and they can be made either from one layer of polyethylene film, we call it monolayer film, or like the schematic drawing shows, 3 layers, which is more common, which is called co-extruded film. If we then look at the right-hand schematic drawing, that would be a laminated structure. So you still have a polyethylene film to start with. This film is made, the laminated film is made in a 2-step process. So you have the polyethylene film, which you by an adhesive glued together with the top substrate. The top substrate is typically made out of other material than polyethylene. It can be polypropylene, it could be PET, and in some cases can be polyamide. Why do you do laminated structures? One is that the top substrate can contribute with some stiffness to your package, so you get more of a body to your package. But you also see from the schematic drawing that the printing is done on the back side of the top substrate, which makes the printing look better. If you want to, you can include barrier properties into a laminated structure, but barrier properties are not needed in frozen food because the food is frozen. And as this film has to be made in a 2-step process, it is also more expensive. But the most important comment on this slide is that since you have top substrates of other material than the polyethylene film, it will be difficult or impossible to recycle these film in the existing recycle streams. The polyethylene you need to have the polyethylene there because of its low temperature performance and its sealing performance. But the question is whether you need to have other material than polyethylene on the top. So there are questions to be asked is, do we need to use a laminated structure? Can we get positive attention for a more sustainable packaging type if we move away from laminated structures? We will discuss this more. What can be mentioned here is that there is no clear definition between when you use a non-laminated versus a laminated structure. Amelie will talk more about this in the next few slides, but the common theme seems to be that there are geographical differences, but also that the more expensive on a kilo cost the food is that you pack, the more likely you are to go to laminated structures. So Amelie, please share our study.
Yeah, indeed. Thanks, Marcus. So at ExxonMobil, we conducted reverse engineering studies in 2012 and in 2019. So before showing you the results of our 2019 study, I will first briefly explain you the objectives and methodologies that we have used. So the objectives, so obviously we want to understand the most common frozen food packaging types available in the market in Europe. We also want to confirm whether the market reference or the most common packaging type can be improved from a sustainability, recyclability perspective, and also potentially a cost perspective as well. We also want, by repeating the study, to identify potential trends between 2012 and 2019. So what did we do in the end? We collected frozen food packages in supermarkets throughout Europe, so both in 2012 and in 2019. And then all those packaging units were analyzed at our ExxonMobil Chemical European Technology Center in Belgium. So now on that page, I want to explain a bit further the different lab analysis techniques that we have used. So you need to read that page as 2 sets of data. So at the top, you have graphs related to a typical non-laminated freezer film. So in that example, it's a 3-layer PE structure. And then at the bottom, so the three charts at the bottom are related to a typical laminated freezer film. So in that example, it's PET, which is the substrate laminated on a PE layer. And then we have, for those two samples, we have used three techniques. So the first technique is the microscopy analysis. So with that method, we can identify how many layers there are in the packaging structure, and we can also measure the thickness of each layer. Then, second technique, infrared analysis. So we pass a beam of infrared light through the freezer film, and then we get a spectrum, and that spectrum is a characteristic of the sample structure. So with that method, we can really identify which type of polymer is used in the packaging structure. For instance, whether it's polyethylene or polypropylene or PET, right? And then third and last technique, DSC. So DSC stands for differential scanning calorimetry. So it's a very complex name, but it's a thermal analysis. So in that case, we measure the amount of heat required to increase the temperature or to decrease the temperature of the freezer film. And then we compare that data with a reference. And we can go even further. So, for instance, with the infrared, I've just said we can identify whether we have PE in the freezer film. And with DSC, we can even identify the polyethylene product subfamilies, whether it's low density, for instance. Low density PE can be identified with that technique. Now I want to show you the results of our 2019 study. So first I will cover the non-laminated freezer films samples, and then I will move to the laminated structures. So non-laminated. So here you have two charts at the bottom. So on the right-hand side, you have the number of samples on the vertical axis, and then horizontal axis, you have the thickness of the film in microns. And then on the left-hand side, again, vertical axis, number of samples collected, and horizontal axis, you have the package content, right? So what can we see from those two plots? So first of all, 24 non-laminated samples were collected throughout Europe. And mainly, you can see in dark blue on the right-hand side plots, you can see that the most common structure is a co-extruded three-layer structure, right? As mentioned by Marcus, even with non-laminated freezer film structures, you can get several layers, all with PE. So that's the most common structure, so in dark blue. And then in terms of thickness, the most common thickness is in the range of 50 to 54 micron. And if we do the average calculation, we are at 55 on all the samples collected for non-laminated freezer film, right? And as mentioned a bit before by Marcus, you can see we collected lots of, let's say, raw type of food like vegetables or fruit are typically packed in non-laminated freezer films. Now I'm moving to the laminated samples. So in total, 26 samples were collected and analyzed throughout Europe. So at the bottom, you have the same two graphs as before. So on the right-hand side at the bottom, you have the thickness. On the left-hand side, you have the package content, and then you have an extra plot for the laminated samples showing the substrates in use, right? So again, the vertical axis, number of samples, horizontal, you have the different type of substrates, PP, PET, PA, and PE. So again, very wide range of film thickness. So here we are talking about the total film thickness. So the thickness of the substrate plus the adhesive plus the PE layer, right? But the most common thickness is in the range of 70 to 74 micron. and average is 72. Then the PET is the most common substrate as well. And we also, you can see that on the plot at the top, 4 samples were monomaterial solutions, so full PE laminated solutions. So those are good solutions. I mean, they are recyclable, contrary to the other ones with multi-material structures. So now we want to share with you the trends, the conclusion we can draw between our 2012 study and 2019 study. So for the sake of time, I will not show in details right now the 2012 study results, but they will be available as backup slides, and we'll distribute the package to all of you. So the message is, first, for non-laminated freezer films, on average, downgauging, so reduction of the thickness of the film, did occur over the last 7 years. So that's great. On average, we are talking about 15% downgauging. So typically in 2012, the average thickness for non-laminated freezer film was 65 microns. And in 2019, as mentioned before, we are at 55. But still, there is room to further reduce that thickness with ExxonMobil performance polyethylene products, and Marcus will further explain that later on. So it means that for now, the penetration of the, let's say, the thinnest solutions are not yet, all those solutions are not yet on the market, despite sustainability benefits and also cost benefits, as mentioned by Richard in his introduction. Now, if we compare the results of 2012 versus 2019 for laminated freezer films, so similar comments, downgauging did occur, on average 12%, based again on the samples that we collected in 2012 and in 2019. And the downgauging is coming from 2 elements. The first one is the substrate switch. So in 2012, the main substrate was PP at that time, with an average thickness of 21 microns. In 2019, the main substrate is PET, with an average thickness of 12 microns. And then the second element explaining the downgauging is also that the PE layer has also been downgauged over time. But in 2019, still we have identified lots of very complex structures, multi-material structures with PE, PET, or PA. So those structures, that complexity is driven by performance and shelf appeal, potentially. But those structures might be under big pressure for recyclability reasons. So on that, obviously, there is also room to move to more sustainable solutions, and for instance, full PE lamination solutions with ExxonMobil performance polyethylene grades. Marcus, again, will further explain that in a minute. And then in 2019, lots of the laminated freezer films are used for costly type of food like fish, meat, ready-made meals in Europe. And then in some geographies, so for instance, in Eastern Europe, even raw vegetables or pieces of fruit are packed in those complex laminated structures. On the contrary, Northern Europe and Western Europe are leading in terms of moving to thinner and recyclable packaging solutions. Marcus, up to you now to further explain the optimal solutions that are available.
Thank you. So, as I said early in the presentation, we are one of the leader when it comes to research and development. So this, the possibility to push the boundary further and go thinner, it's made possible by our performance polyethylenes. And we have currently 3 different product families, Exceed, XP, and Enable. We launched the Exceed family in 1995, and the difference between these and standard polyethylenes is that thanks to the catalysis process, when the polymers are made, we can better control and tailor the structure of the molecules. And so we came up with a technology that is now licensed to many others in the market in 95. And then we have added on with other product families. And the examples I'm going to show now in the next slide is based on Exceed XP and Enable. So the first section here is reduce with performance. So this is about making your packaging film thinner without losing or sacrificing your performance. And I want to make it clear that ExxonMobil is the raw material supplier. So our customers are extruding a film and convert it into packages, for example, frozen food. So here on the first slide, I take a non-laminated solution example. On the left-hand side, you see a number of mechanical parameters. They are selected because they are important for the performance of a freezer film. So you see tensile strength, for example, that's the toughness of the film. You see gloss, that is how shiny the surface looks. Dart impact, that measured on dropping something on the film. MD second modulus, that's measured for stiffness. Puncture force is measured on slow penetration of the film. And minus 30 degrees backdrop test is, as it sounds, we have put freezer film bags into minus 30 degrees and then making drop tests to measure the performance. The graph below is, in fact, the sealing performance. So the gray area and the gray line, that is the reference. In this case, it's a market reference of 60 micron thickness. So it's a little bit thicker than the average of 55 microns that Amelie just presented. From the graphs, you just see that the axes are made in such a way that you want to cover as large area as possible. So larger area is better. So you can see even that we compare a 40 micron ExxonMobil solution based on Exceed XP and Enable, we have similar or better performance. And on the bottom graph, it is shown sealability. So how fast it seals in your packaging lines, and a curve higher is better. So you see sealability is also better than the market reference. So in this case, we prove a thickness reduction up to 1/3, similar or better performance, and lower cost per package. And I want to make a comment here on the cost side, because we should keep in mind that the performance polyethylenes will be more expensive on a kilo basis. But thanks to the fact that you need to use far less, the cost will be lower per package. So this is something that's very important to keep in mind if you want to go for these kind of developments, is that all cost or price discussions should happen on square meter basis and not kilo basis. So this is the non-laminated solution. And if we go for the next slide, it's the very same graph, but for a laminated solution. The difference here is, in fact, that the two polyethylene parts, they have been laminated together with the 12 micron PET substrate. So the mechanical data as well as the sealing performance, they are now measured with a substrate on top. And you see that the difference is much smaller, and that comes from the fact that once something is laminated, that the substrate dictates to a large extent the mechanical performance. So you see that now the performance is pretty much same, except for the minus 30 backdrop test. And also you see that the difference in sealing is less significant. But again, it is proven that you can do significant downgauging of the polyethylene part also in a laminate. And I also promised you that we should spend a little bit of time talking about design for recycling. If you go to any conference or seminar these days around packaging, they will talk about design for recycling. So what does it mean? So if we go for next slide there, design for recycling is the fact that you start thinking about how recyclable is my package? End of life. Can it be fed into mechanical recycling in the pellet stream? And this is a no-brainer for the polyethylene non-laminated films, because you have polyethylene recycling streams, and as long as you don't mix material, it's fine to do mechanical recycling. But this is the laminate example. And you see the left-hand example here is the same as I had in my introduction page on the structures available. You see that the substrate can be PET, polypropylene, or polyamide. And in the case study showed by Amelie, you saw that all the examples except 4 were actually based on PET, polypropylene, or polyamide substrate. So what happens when you put these type of film into mechanical recycling? It will deteriorate the quality of the recycled pellets that comes out. And the simple reason to that is that these polymers are not compatible with polyethylene, especially not PET and polyamide. Polypropylene can be compatible in a certain percentage, but it should be very low. So a design for recycle example would be to replace the PET, polypropylene, or polyamide substrate with a polyethylene substrate. This is you have to look at case by case, depending on how stiff you need it, what kind of optical performance you need, etc. But the solutions with PE substrate can be made to match very closely, not exactly, but they can be very close. And this very example in the US has been qualified with the green-blue label. That is the how to recycle store drop-off label. So that is a sustainability kind of qualification, but that's a US one. But just to show you that this is a way to reach more sustainable solutions. So let's summarize on the next slide. There are several ways to make your frozen food packaging more sustainable. So number 1 is to do more with less. So Richard touched on this in his opening, and this might be the very most obvious one, is to reduce the headspace in your package. Secondly, you can reduce the film thickness. So you can, if you have a non-laminated structure, you can reduce the polyethylene. In a laminated structure, you can reduce the polyethylene part, but you can most likely, we are not experts in these materials. We don't have the PET and the polyamide, but most likely you can reduce further also those material a little bit. Other ways of making your freezer film more sustainable is actually to move away from laminated structures. So moving from laminated structures to non-laminated structures. That will change the touch and feel of your package, and it will change the appearance of the package. On the other hand, that might be good in the perception of consumer these days, if you can make claim that the package is now more recyclable, etc. And then the last one here to make your packages more sustainable is that if you determine that, no, we need to stay with a laminated solution, you can go for a monomaterial laminated solution where you have polyethylene as the substrate. So, to conclude this, we believe that the path forward is collaboration. One of the things we want to offer you is, unless you are fully aware of what structures you are putting on the market when it comes to freezer film, we are happy to benchmark them for you. So if you send us a sample of your freezer films, we will do the analysis and we will put them in our study to share with you what you have, how thick they are, and if there is room to improve them. And we believe that the collaboration can push a market-wide change. And we are happy to discuss new packaging solutions with you. And I can tell you that as we speak, we have these developments in mainland Europe being out for end-use approval. So they are in the freezers currently at supermarkets being validated. So it is progressing, and we would like to extend our collaboration to you to see what we can do to improve and change the UK market. That's it, Richard.
Okay, so, well, thank you very much to Marcus and Emil. If anyone's got any questions, please post them. We haven't seen anything come up at the moment. Marcus, you made a point that you said you've got some of these films on test already in the European market.
Yes.
In which direction have they gone?
So the current solution that we have on the market for end-use testing was decided to go for 42 micron. It was a non-laminated solution, and the reason why 42 was chosen was mainly due to the fact that the converter's machine ran best at 42 micron. So it was a kind of performance, but also processability decision to go for 42. So they could increase their output when they went to 42 instead of 40. And that solution is based on those I showed during Amelie is putting slide 26 on. So it's based on this one. The way we work is that we share those formulation, our starting formulation, widely with any of our customer or converter who wants to produce or test this. But then our technology people will assist and help and to modify our starting position to fit their equipment. Every equipment is slightly different, and for different reasons, you might have to modify the actual recipe you're running on your line. But that's something that we at ExxonMobil support our customers with to find the ultimate solution, both for the end-use application as well as for our customers' equipment.
And what category is this trial taking place in? You highlighted that vegetables was a very big area for the use of form fill.
I will have to follow up on the content being packed. I don't have that information at hand.